Welcome to the Gen AI Daily Briefing for Monday, August 24th, 2026. The most interesting thread today is that the frontier conversation is shifting from raw model release theater towards system design. Agents, memory, routing, long context efficiency, and domain benchmarks that actually expose where today's models still break. First up, a startup called Inherent, founded by DeepMind alumni, says its research agent Faraday outperformed Anthropic and OpenAI systems on replicating scientific papers. That's a stronger claim than the usual helped summarize a paper benchmark. Replication is messy. It means extracting methods from imperfect text, resolving ambiguities, setting up code or experiments, and dealing with the fact that many papers are underspecified. If the result holds up, that matters because paper replication is a very practical proxy for whether an agent can do real research operations instead of just polished reasoning demos. The broader significance is architectural. The winners in this category probably won't just be the largest base model. They'll be systems with better tool use, better memory of intermediate hypotheses, tighter verification loops, and stronger failure recovery. In other words, the stack starts to look more like software engineering plus lab ops than chatbot UX. For engineering leaders, this is a reminder that agent performance is increasingly an orchestration problem. Model IQ helps, but state management, test harnesses, and reliable evaluators may decide who actually wins deployments. Next up, a new benchmark called VIALS is worth attention because it hits a real enterprise pain point. It evaluates vision language models on life sciences artifacts like gel blots, microscopy, plasmid maps, flow cytometry plots, and molecular structures. The key finding is that models that look fluent on general image tasks still struggle badly on these specialized visuals. That's not surprising, but it's important. Internet-scale multimodal pre-training gives broad visual competence, not instrument literacy. For biotech and pharma teams, this is the difference between a demo and a workflow. Reading a Western blot or a flow plot is partly visual and partly procedural. It depends on conventions, edge cases, and tacit domain priors. You can't assume GPT-style multimodal competence transfers cleanly into regulated or lab-heavy environments. Expect a lot more vertical benchmarks like this, and probably a wave of retrieval plus specialist fine-tuned systems rather than one giant generalist model doing everything. Worth flagging from the security side, a paper on agent memory poisoning shows a pretty nasty failure mode for persistent memory agents. The headline result is that poisoning just 1.2% of a memory corpus dropped accuracy from 0.85 to 0.30, and a multi-stage write time screening pipeline failed to catch the poison entries. This is important because the industry has spent a lot of attention on prompt injection, but persistent memory is arguably the more operationally dangerous surface. Why? Because once bad information gets written into memory, it becomes durable and self-reinforcing. It can be retrieved later under apparently benign contexts, and then used as if it were trusted state. That turns memory into a compromise amplification layer. For architects, the design implication is pretty clear. Long-term agent memory should be treated more like an untrusted database than like an extension of the model's context window. You need trust scoring, provenance, conflict checks, decay policies, and ideally verification before high-impact reuse. Store now, reason later is starting to look like a dangerous default. On the inference side, there's a useful paper on memory-augmented chain of thought compression. The basic idea is that you can substitute some generated reasoning tokens with reusable reasoning memories, reducing decode cost without fully losing the performance gains of explicit chain of thought. This matters because inference economics are now a first-class product constraint. A lot of teams have discovered that the smartest model isn't the most deployable one once you multiply long reasoning traces across millions of requests. What's nice here is that the approach is training-free. That lowers adoption friction. More importantly, It formalizes something practitioners already feel. Not every task needs fresh verbose reasoning every time. Some reasoning patterns are reusable structures. If this line of work matures, expect production stacks that separate reasoning cache, task memory, and response generation much more explicitly. That could become a meaningful lever for both latency and serving cost. Closely related is a paper called E2 TTT on test time training for long context processing. Test time training has been attractive because it lets models adapt weights during inference, which can improve long horizon context handling. The catch has been efficiency. Per token updates are expressive but ugly on hardware. Chunked approximations are faster but lose fidelity. E2 TTT claims an exact chunk-level state transition that reproduces the chunk-in, fast weight, and momentum states of the per-token recurrence. Translation: it tries to keep the adaptation benefits while making the computation more parallel and accelerator-friendly. If that pans out, it's another sign that the long context race is becoming less about ever bigger windows and more about smarter state update schemes. A million-token context is nice marketing. Efficient adaptation over useful chunks is often the more practical systems win. Another technically interesting paper is RARE, which looks at representation steering in mixture of experts models. The core observation is that if you naively steer hidden states in MO, you can unintentionally perturb the router and send tokens to the wrong experts. That's a subtle but very real issue. MOs are not just sparse dense models. The routing decision is part of the computation. RARE proposes decoupling steering from routing, so you preserve expert selection while still modifying behavior. That matters because MOs are increasingly common in frontier and cost-sensitive deployments. If your alignment, style control, or policy edits accidentally scramble routing, you may be measuring a routing artifact rather than a clean behavioral intervention. This is the kind of systems nuance that will matter more as teams move from dense model research assumptions into production architectures that are sparse, sharded, and highly optimized. On the market and policy side, OpenAI says California should strengthen SB 53, which is a notable reversal from prior opposition. The obvious read is politics, but there's also a market structure angle. Once you're an incumbent, clearer rules can be strategically useful. They raise compliance costs, but they also turn safety process and reporting into a competitive moat. The interesting question is whether state-level safety law starts converging on operational controls around evaluation, incident reporting, and deployment thresholds, rather than broad model size triggers. That would be more annoying for labs, but probably more actionable for enterprises trying to map internal controls to external requirements. And finally, there's the weird but telling item of the day, the mysterious Ox Alpha model. At the moment, there's more speculation than substance, but the market signal is still interesting. People are eager for a credible new frontier entrant, especially one that might upset the now familiar closed versus open lineup. The fact that a stealth model can generate real buzz so quickly tells you two things. First, users still think meaningful capability jumps are possible from unexpected players. Second, the industry's brand hierarchy is not yet settled. There's room for a new lab to matter if it can pair real evals with believable infrastructure and developer trust. What to watch next? Whether research agents move from benchmark claims into reproducible enterprise workflows. Whether memory security becomes a default design discipline for agent platforms. And whether long context innovation keeps shifting from brute force window expansion toward adaptive inference and reusable reasoning state. Also keep an eye on domain benchmarks like VIALS. They may end up being more predictive of commercial value than a generic leaderboard churn. That's your briefing. We'll see you tomorrow.